This lesson deals with supplemental problem 16.1. You can find this problem in the ECE202 ebook in the chapter 16 supplemental problems on page 1. Given an industrial load where we have 30 kilowatts of power consumed by heating elements and 150 kilovolt amperes consumed by motors operating at a lagging power factor of 0.6. Suppose that this plant has an input voltage of 4,000 volts RMS. Could you figure the total current and the power factor of the plant? Power consumed by the resistive elements is just purely real, so it's going to be 30,000 plus J0 volt amperes. S2 has got a magnitude of 150 kilovolt amperes and has an angle that is the arc cosine of 0.6, and that's 53.13 degrees. Putting that into rectangular form, 150k times the cosine of theta, get 90k. 150 times the sine of theta, I get 120k. And again, the units on here will be volt amperes. So our total power consumed then is the sum of these two. We're going to add the reals and add the imaginary, so I get 120,000 plus J 120,000. So that gives a magnitude of 120k times the square root of 2, which is 169.7k, at an angle of 45 degrees, and again, the units are volt amperes. And that's the magnitude and angle of our complex power. The overall power factor then for this total would be the cosine of the angle plus 45 degrees. So it would be 0.707, and because it's positive, it's lagging. And lastly, the magnitude of the total complex power is equal to the current times the voltage in magnitude. So it would be the voltage RMS times the current RMS. And then we could solve for the current by taking the magnitude of our complex power, which is 169.7K, and dividing it by our 4,000 volt input. I get 42.425 amps RMS. And this is supplemental problem 16.1.